All right, so 25, you guys, is your first introduction to the Heparin Protocol. If you looked at this and said, what do I do with this? Well, you are at the right point. And if you, also, if you haven't been on my YouTube channel where I've worked this out, you can see that, but we're going to do this here live as well. So the trick here is you don't need to answer everything that's listed in the steps of the protocol. The steps 1 through 15 is just the standard Heparin protocol. So if you did a Google search for Heparin protocol, this is what you would see. You would see where it says, like, you know, what the CBC should be, what the GAIAC stool suit should be, what the neurocheck should be. Those are not things you need to fill in. All you need to be able to do is answer the questions that are below the protocol. So where it says A, B, C, and then C has part 1 and part 2. So I'm going to show you how to navigate this and show you what the important parts are for when you see this on your test next week. So first things first, we have to account for the patient's weight, and we have to convert the patient's weight from pounds to kilograms. So you have a 110-pound individual, and we're going to convert that to kilograms. That's 50 kilograms. Okay, so if you did that, you started off right. You're doing everything right. Now, the protocol at the beginning, right next to 25, it says protocol, and then it says bolus patient with heparin 80 units per kilogram body weight and start drip at 18 units per kilogram per hour. You will see that same statement repeated in step 10 of the protocol, where the protocol says bolus with 80 units per kilogram, start drip at 18 units per kilogram per hour. So to question A, or the first part of this question, is calculate the number of milliliters to administer for the bolus. So we're going to start off with A. 50 kilograms is our patient's weight, and we're going to multiply by what it tells us to, which is the 80 units per kilogram. Does everyone see where I'm getting the 80 units and the 50 kilograms? If not, just chime in and say, no, I don't know where you're getting that information from. 80 times 50 is 4,000 units. We've accounted for the kilograms, so we can just eliminate that. I want to make sure that you can see that that's a 5, not a 3. Now, if it asked you, or the question asked how many units to administer for the bolus, we'd be done, but it asked how many milliliters. So we need a way to convert units to milliliters. So we go into the protocol, and if you look at step 2 of the protocol, it states heparin 25,000 units in 250 milliliters, half normal saline, bolus dosage strength 1,000 units per milliliter. We're going to use that bolus dosage strength to convert our units to milliliters. So times, we don't want units, we do want milliliters. And our answer for A is 4 milliliters. Now, I've been doing this a lot. For the initial bolus, these are the constants, and especially for a bolus. What I've marked in red are the constants. So the only thing that's going to really change, and the only thing that I can change, or what your instructor can change, is the patient's weight. So if the patient weighs 200 pounds, if the patient weighs 187, whatever that case may be, all you got to do is convert that from pounds to kilograms, and then multiply by 80, divide by 1,000. And that's how you do it.
So when you say it's constant, do you mean that is the equation for it then?
Right. Well, I wouldn't say it's necessarily the equation, but it's the numbers that you'll use.
Okay.
Okay. All right. Now the drip, the infusion rate. So part B says, what's the infusion rate in milliliters per hour? So first thing is, we have our same patient that weighs the same amount, 50 kilograms. And we're going to multiply by what it tells us to do, which is 18 units kilogram hour. So for the initial infusion, that's another thing that's considered a constant. Okay. So when I'm saying constant, I'm just saying that would be for this problem for a heparin protocol, what I'm putting in red would always be the same thing. The only thing that's going to differ is weight.
So the heparin protocol is the 18 units, the 80 and 1,000 units, correct?
Right. And all we're doing is following what it tells us to do for the bolus and for the infusion rate. Yes. All right. So 50 times 18 is 900 units per hour. And then we need a way to convert units to milliliters. So we go back to step 2, and step 2 says we have an IV, we have a normal saline bag of heparin with 25,000 units of heparin and 250 milliliters of normal saline. And so that is what we need to use to convert units to milliliters. Now, the reason we use that instead of the bolus is because we only use the bolus to calculate bolus, and we only use the IV bag to calculate the infusion rate, the flow rate. Again, as far as that, this is what you would use for when you're calculating the flow rate. On an aside, this right here is the same thing as 1/100. So if you are putting together your own little formulas, that's how you would do that. And then you would get your answer, which is 9 milliliters per hour. So initially, we're going to do a bolus at 4 milliliters, and then we're going to set the infusion rate to go at 9 milliliters per hour. And where I'm getting this information here is from step 2 of the protocol. All right. Now, this would be an example of what a question would look like on your test. It would just be answering these 2 questions, A and B. You would not need to worry about the C parts 1 and 2. The reason I wrote it out that way is so that you could have additional practice. So on the test, you're either going to get this question, A and B, or this question, C1, C2. And that's how you see that. So let's go ahead and I'll show you how to do the next parts. So C1, we're doing the same thing. We're calculating a bolus, okay? However, before we can calculate the bolus, we don't need to re-bolus with the same amount, or maybe we do, it just depends. So what part C says is after 6 hours, so they've been on this protocol of 9 milliliters per hour after the 4 milliliter bolus, after 6 hours, we check their APTT and we see that it's 43 seconds. Then I go back up into the protocol and I look for where does 43 seconds fall in the range of APTTs. And so you look at steps 11, 12, 13, 14, and 15 for that range. Notice that step 12, 36 to 44 seconds, is where I want to be or where I'm looking for what I do next. So what I do next, it says to re-bolus with 40 units per kilogram and to increase the rate by 2 units per kilogram per hour. So when I go back to part C1, it says calculate the number of milliliters to prepare, and this is for the new bolus, okay? So when I calculate the number of milliliters per prepare, you can do math, or you could simply do half of 4 milliliters, which is 2 milliliters, and you got the right answer. But for practice, I would suggest writing out your 50 kilograms times, now it's not 80 units this time it's 40 units. And it's 40 units because the protocol told us to do that. That gives us 2,000 units. We don't want units, we want milliliters. So in 1 milliliter, there are 1,000 units of heparin. And that's how we get to our 2 milliliters, okay? Again, notice that I'm using this same 1/1000. It's the same thing as the initial bolus information that I used before. So I don't change. Bolus sticks with bolus. The rate one sticks with the rate one, okay? Again, for step 12, so I'm just going to indicate and just write next to this. I can write step 12. Step 12 is what tells us what to put in that box. What that means is, let's say I gave you an APTT of 47 seconds, then you would follow that. Protocol. If I gave you an APTT of 30 seconds, then you would follow that protocol, okay? Or that step in the protocol. All right, C part 2. C part 2, now we're going to calculate a new infusion rate. So 50 kilograms. Now it tells us to increase the rate by 2 units per kilogram per hour. Our initial rate was 18 units per kilogram. So you were going to add 2 to the 18. When you add 2 to 18, you get 20 units per kilogram per hour. That gives you 1,000 units per hour. We don't want units per hour, we want milliliters per hour. So I'm going to use the infusion rate constant, I guess we can call that, or just basically what's in the IV bag, and we're just resetting this. So that's where you use the 250 ml and the 25,000 units of heparin. Again, you know you've done it right because you've eliminated everything but what you're looking for, which is milliliters per hour. And your answer is 10 milliliters per hour. Again, this is a constant that I'm following. That's the same thing that we saw right here with anytime we do these infusion rate problems. Also, just as an aside, what we did in part B and part C2 is the exact same thing that you did in numbers 22. So I'm going to write that here. So numbers 22 and 23 are question numbers 22 and 23 on your practice test are variations of part B and part C2. I realize that you've never seen this before, but a lot of times just seeing how to solve it, if you did it another way and you got the same answers, you're doing it right. But it's just a way to at least give you an idea of how to solve these types of questions. Are there any questions from the Heparin protocol here? What I did, where I got it from?
You lost me on C1 and 2.
Okay. So help me out. Where did I lose you?
I don't really know. The 20 units is from the ATP,
Yes.
right? Okay.
Yeah, so we were already infusing at 18 units per kilogram per hour, which ended up being 9 milliliters per hour for this patient at this weight. And then when it tells us to increase by 2, we just add 2 to 18. So 18 plus 2 is where I got the 20 units from.
Okay.
If it told me to decrease by 2, then I would do 18 minus 2, and that would be 16. Or if it told me to increase by 4, or increase by, or decrease by 3, whatever it tells me to do, I'm basing it off of the original drip, the original start drip. And like I said, if you're sitting there going like, I've never seen this before, you're absolutely right. You haven't. And I don't even know if you'll see it this semester. I don't know. But you will see it on your test next week. And you'll probably see it again 4th semester. And honestly, most people don't have a problem with this question once you've done it a couple of times. I also will tell you, let's say you get both questions wrong. So let's say you do A and B and you miss them both. You only missed 1 point. So if that gives you a little bit of a breather, sometimes that's good. All right. Did that help to clarify for C1 and C2?
Yeah.
Okay. If not, just let me know because I wanna make sure you understand it.
Yeah, I mean, I get it. I just have to do it, I guess.
Right. And that's what it comes down to. You just got to practice it. And like I said, the only thing that I can do to this problem to make it different is just I can change the patient's weight or I can change the APTT results. But the protocol itself, the steps 1 through 15, that's standard. I can't change any of those things. So you're not going to see like start a bolus at like 100 units per kilogram and then start a drip at 9 units per kilogram. You're not going to see that.
So do we have to memorize the steps 1 through 15?
No. This is the way it's written is how to be written on the test.
Okay.
Yeah, you do not need to you do not need to memorize it. You just need to know how to access the information and utilize it. That was a good question. All right, well, since it was already asked, I'm just going to work through a couple of other questions that might be helpful for you as well. So I'm going to go ahead and clear this off. I'm recording this. I will be posting this on, like I said, my YouTube channel. And then if you want the link to the Zoom, just let me know and I'll make sure you get the recording. So let me go ahead and clear this out. All right. So the first one that someone asked me about was question 13. And for this one, this is actually a good one to see, especially after what we just did. So it says that you have dexamethasone, sodium phosphate, 5 milligrams intramuscular every 12 hours. The patient weighs 127 pounds and the strength in the vial is 4 milligrams per milliliter. How many milliliters will you give? So the first thing you have to ask yourself is, do I care what the patient's weight is? You might care based off of the medication, but as far as math is concerned, the patient's weight does not get involved. The only reason that the patient's weight would get involved if it said to give him 5 milligrams per kilogram body weight. If it said that, then we need to work in the patient's weight. But since it doesn't say that, all we're going to do is take the 5 milligrams, which is what was ordered, divide by the 4 milligrams per milliliter, and then you get, what is that, 1.3 milliliters. And that's how you say it. The actual answer is 1.25 milliliters, but then you round that to 1.3. Okay. So that's how you do question 13. The next one that was asked was question 20 and 21. So 20 and 21 are your reconstitution questions. For question 20, you just need to choose the strongest concentration of the 3 that are listed there because it tells you determine the volume in milliliters for the strongest concentration. The strongest concentration that's listed there is 20 milligrams per milliliter because it's the most milligrams given 1 milliliter volume. So you just take your order, which is the 60 milligrams, divide it by the 20 milligrams per milliliter, and you get 3 milliliters. That's how you answer that question. For 21, this one's commonly missed because of the milliliters diluent added. When you see that table, you can just ignore it. What milliliters diluent added tells you, and it would be listed on the actual on the label for the medication. It just tells the pharmacy, or it tells you as the nurse how much deionized water to add to the powder that's sitting within the container. If I add 18.2 milliliters of water, I'm going to get a more dilute concentration than if I only add 3.2 milliliters of deionized water. If I add 18.2 milliliters of deionized water, that will give me a concentration of 250,000 units per milliliter. And if I only add 3.2 milliliters, I'm going to get 1 million units per milliliter. So what that tells you is when it asks you to calculate milliliters and then use the strongest dose, strongest concentration, again, the strongest concentration is the one with the most per volume. So for this one, it's 1 million units per milliliter. So your initial question says, or your initial order is the 350,000 units. 1 million units is the strongest concentration per milliliter, and you get 0.35 milliliters. Now, one of the things I usually add to this, just because you're going to be using a basic 10 key calculator when you do these math problems, sometimes you might miss a zero. So what I do is look for the number with the least amount of zeros, and then cross out. So here I can cross out 4. I'm going to cross out 4 here. So 35 over 100 is much easier to plug into your calculator and not make a mistake on than is 350,000 over 1 million. So 0.35 milliliters. Now for this, you would not round that answer to 0.4. You would leave it at 0.35 milliliters. A number less than 1, go to the nearest hundredth. If it's a number greater than 1, so let's say I had 1.35 as my answer, I would go to the nearest tenth, so I would make that 1.4 if we had a number greater than 1, but we don't, so that's what that is. All right, 22 was also asked. Any questions on any of these three? If you have one, just pop in. So 22 and 23 are good because they're good practice for your heparin protocol. All right, so people ask me sometimes like why where I'm going to start and why I start there. So first of all, 22 is asking you the same thing that part B and C part 2 of the heparin protocol are asking, which is to find the flow rate and make a conversion from units per hour to milliliters per hour. So the way I rationalize that is I'm basically just going from one flow rate, designation to another flow rate designation. It's a conversion just with flow rates. So I start with the flow rate that is given. So it tells me 1,000 units per hour for my flow rate for question 22. And then what is flowing is the 25,000 units of heparin in 1,000 ml IV. So 25,000 units, 1,000 ml. So I know just from doing dimensional analysis, whether you like that or not, doing dimensional analysis will help me to eliminate the units that I don't want and then keep the units that I do want. In this instance, it's milliliters per hour. So you would just do this and you would get whatever that comes out to be. So I think that's whatever 25 into 1,000 is. Is that 100 or 400 or something like that? Actually, I can just look up the answer. I have it here. 40. Oops. 40 milliliters per hour. Notice that this looks very similar to what you did in the heparin protocol, except your heparin protocol was 250 ml per 25,000 units. That's the only difference. For 23, it's the same thing. 23, we're going to do the 10 units per hour. And again, remember, I decided to start with the 10 units per hour because I'm going from one flow rate, units per hour, to another flow rate, milliliters per hour. So I just start with that. And that helps me to organize where things go in case I get stuck or lost. Okay. Then I'm going to look at what I have here, and it's 500 units. I'm trying to get rid of the units, and then 500 milliliters. So this ends up being just exactly the same, 10 milliliters per hour. Now, if you're trying to do desired over have for any of these questions, it'll work. You just got to remember where you're putting things. For 23, so I'm just going to write the desired over have version in a different color. We'll do it in red. So for this one, you can do 1,000 units per hour over the 25,000 units times the 1,000 ml. So if you like that ordered over half times quantity, this will also equal the 40 ml per hour. And then for this one, it would be the 10 units per hour divided by the 500 units times the 500 ml. And like I said, that will also give us 10 milliliters per hour. It doesn't change the answer. It's just another way to set it up. But some of you like the order over half times quantity. Some of you like dimensional analysis. Most of you don't like any of it, and I completely understand
True.
that. All right. Are there any other questions?
I actually have a question. For number 24, is that essentially the same thing as number 22 and 23? It's just asking what time the IV is going to end?
So the difference with 24 is you just need to know, actually it's not the same, because all you're doing is finding out how many hours it will infuse at. So let me go ahead and work that one out. So 24 says we have 1,000 milliliter bag that's infusing at 50 milliliters per hour. And then 50 goes into 1,000 20 times. So we have 20 hours, okay? After 20 hours, we want to know what time it's going to be. And so the way that I did this, and you probably already got this right, is if it started Monday at 8 a.m., and then let's say it was 24 hours later, then that would be Tuesday at 8 a.m. But since it was only 20 hours, we just subtract 4, so your answer would be Tuesday at 4 a.m. So in this instance, we're not converting, we're not going from milliliters to hour to units per hour, which is how I would describe what's happening in 22 and 23. We're just wondering how long our infusion pump is going to be running for.
I had a question about that one.
Yeah.
I know that in like the very beginning of our little packet, it says you're supposed to use military time, and the answer in there isn't in military time. And I didn't know how nitpicky they were because I didn't want to get busted for like writing 4 a.m. instead of 0400. Do you know any better?
So I'm just looking to see if they tell you to use military time, then go ahead and use that. The other way around that is you can say Tuesday at 4 a.m. or 0400. I mean, you could just write it out right next to it. But if they tell you specifically that they want it in military time, then go ahead and do that.
Gotcha.
Yeah. The trick to military time is after you get past noon, you just add 1 until you get to 11. So the max is 23, and then you start back at 0 again. And then you can look that up. You can do a Google search to just look at the variations of times, and you can practice that. I honestly, I don't even remember if this question is on your actual test, but it might be. So you've seen it. So.
All right, so can we go to number 15?
Absolutely.
I just forget what they want specifically. I don't know if they want the regular first and then the MPH after that.
Yeah, so and this is good. I'm glad that you're asking this. And then I also, in that link that I shared in the chat, there is there's a document in there that shows you where I got the information, what I'm about to show you, and it came just from a Dosage Calc textbook. So basically, when they ask you, first of all, the question for question 15 says you have 10 units of regular insulin and 40 units of NPH. Which syringe do you use? And then which solution and amount do you draw up first? And what is the total number? So yeah, so here you go, Lauren. Give me 1 second. Okay, and it's right there. I also included my email address and then my YouTube channel if you don't already have that. All right, so for this, what I'm going to do is first tell you where with a bullet point where it says solution amount to be drawn up first. I'm going to tell you, go ahead and write the 10 units or whatever the number is, regular first. Just make sure you denote that so your whomever's grading it knows you know which one to pull up first, okay? then when it says the correct total, you can just say the 50 units total. Now on the syringe, okay, on the syringe, you're going to make a mark. Your mark is going to be at 50 units for your total. So that's your total mark. Then between 10 or between 40 and 50 is actually where hypothetically the regular insulin resides. So you can say in between here is where you're going to find your regular insulin, and then your NPH is going to be over here between 0 and 40. The thing that's like confounding is the fact that when you do mix your insulins, they get all mixed together. So it's not there, but they're just, they're trying to get you to write out where it might reside, and where it might reside is going to be closest to the plunger. If you were in a hypothetical vacuumed environment where you could actually keep the liquids separated, but you can't do, and this is not a physics lab, so we're not going to even try, but this is how they want you to write it. So I've been doing the representation of, the NPH is in the 0 to 40 and the regular is in between 40 and 50. But make sure you denote and write next to the bullet points. Oh, and it's always going to be syringe B, so make sure you circle that because I don't have any other images of this, but it's the one that says units on it in case it is a different picture. All right, are there any other questions?
If you can do this entire packet, do you think you'll be okay on the test?
Yes, so this packet was designed, basically what I did is, and this, you can see that these are all labeled 2016, which is the last time these were updated. I made the tests first, then I went back and I changed all the numbers, and I may have changed a few of the drug labels, and followed the same format for the test, which is why I only give you 25 questions, because I mainly do that so you can practice timing, making sure you can finish 25 questions in an hour, especially that Heparin protocol.
Mm-hmm.
And so yes, you will see this. If you can get through this, you should be just fine on the test. I will tell you that the tests most likely have been changed, meaning that your instructors have changed like the numbers and some of the other things that I didn't change. So I don't know what the current test looks like, but it should look very similar to this practice test.
Okay.
I had a question about the rounding, actually.
Okay.
Yeah, because numbers 1 and 2, the rounding answers, I felt like it didn't follow the rule, so I didn't know if it was just a typo or something for questions 1 and 2.
Okay, so first of all, let me just double check the rounding rules. I just want to make sure okay, so when you're doing basic unit conversions, meaning like you're going from milligrams to grams or milligrams to micrograms, you do not round those numbers.
So questions 1 through 4.
Questions 1 through 4, excluding like question 3, because they're between two different units, you're going from standard to metric, then you can round to the nearest tenth when you're going between different unit factors, like I said, from pounds to kilograms, or like teaspoons to milliliters, or vice versa. But when you're going from when you're staying within the metric system, do not round. And that only applies for the basic conversions, like questions 1 through 4.
So for number 1, should the answer be 1.275 grams?
Yes.
Okay.
Yeah, do not round that answer. I'm proud of you guys for being sticklers on the rounding, and it's my fault for not updating the rounding rules to include that the exception there is the when you're doing basic unit conversions, you do not round those.
Can we look
So
at? Oh, sorry. Go ahead.
no, go ahead.
I was asking if we can look at number 5, but go ahead.
Yeah. Absolutely. So number 5 is your fluid replacement question. So I'm just going to show you, this is a formula that I came up with after I've done this a couple of times, and this seems to help get a consistent answer. What you're going to do is you're going to take the actual urine output, so that was 500 milliliters, so that was actual urine out, and you're going to put that over the initial replacement volume reference for urine output. So in this question, it's 125. And then you're just going to multiply by the replacement volume, which is the 40 milliliters in. And when you do that, the only thing I can change all three of those numbers. So I could say, let's say I said for every 200 milliliters of output, I'm going to replace with 50 milliliters of water. And then after 4 hours, it was 1,000 milliliters. So I'm going to set it up the exact same way. I voided 1,000 milliliters, and that's a lot in 4 hours, so we got a problem there. And then I said 100. Did I say 100 or did I say 200? Yeah, we'll just do 100. And then I said 50 milliliters is the replacement volume. So I always put the big out over the little out, and the big and the little, and then multiply by the in, and that'll give us the actual replacement volume. Now, it is possible that you could have less out than, meaning, let's say you're doing the 125 milliliters per 40 milliliters. So 40 milliliters replaced for every 125 milliliters voided. And let's say they only voided out 100 milliliters. You could still calculate a volume there. It would just be a number less than 40.
So for that one, is it whatever the answer is, and then you have to subtract something, or no?
No, you don't have to subtract anything. Yep, it's just
What you
whatever.
get as your answer, right?
Correct. Yep.
Okay.
Yeah. For the question that's stated on the test is 160 milliliters is what the replacement volume would be.
Okay. And then, sorry, for number 3, when you said not to round, because
No. I said you do round when you go from two different units. So when you go from pounds to kilograms, do round to the nearest tenth.
So if it was 123 pounds, or sorry, 124 pounds, it's 50, 56.36. So it would be 56.4. Or
correct.
Sorry, I messed up there. Did I? Okay.
You're doing that right. At least you're rounding right. So.
Okay.
Excuse me, but in the paper it says, with the exception of rounding your answer from conversion of pounds to kilogram.
Correct. So what that exception is pertaining to is, in the beginning of that statement, it says to save all your rounding until the very end of solving an equation. But let's say for the Heparin protocol, for the heparin protocol, let's say you did have like a 124-pound patient. You divide that by 2.2 and you get the 56.36. I think that's what was said. And so you would round that to 56.4 before moving on to doing the other calculations. You would do that as a consistent thing for the weight.
Okay, thank you.
You're welcome.
Can you go over number 17?
Absolutely. Okay. So with 17, a lot of times what trips people up on 17 is knowing that you ignore the 200 milligrams. When we're talking about the flow rate, we just care about the rate, so the volume over time. We really don't care about the strength. Obviously, we care about the strength. We want to make sure we're giving the right amount and strength to the patient that's receiving it. But for math purposes, we don't care. So all we're going to do is take the 75 milliliters over the 30 minutes, multiply by what the drop factor is, which is 10, and then you get 25 drops per minute.
So can we go back to 22 and 23?
Yeah.
So you say you started with 1,000 units over an hour. Then we want to get rid of the units, so you put 25 on the other side, vice versa, and then 100 mLs because we want mLs over 100, right?
Correct.
So we start with okay.
Yeah, you could have started with the milliliters.
No, I like it your way.
Okay. What I'm saying, when I say I decided, I'm just saying like it gives you you get to decide where you start as long as you're, organizing it the right way. And I would recommend that you do it. And also this is consistent with how I showed you how to do the heparin protocol, because you got to a point where you had 1,000 units per hour or 900 units per hour or whatever that was. And then all you're doing is, and what I was saying before is, I don't want units. I do want milliliters. So they tell us that we have an IV bag of 25,000 units that contains 1,000 milliliters, or 1,000 milliliter IV that contains 25,000 units of heparin. So, yeah, if that's what you said, you did everything correctly.
Can we do 25 again?
25 again? Sure. Why don't we do 25, but we'll do a different weight?
Okay.
Since you're on the, there you are. So go ahead and just give me a weight.
100.
Okay. So we have a 100-pound individual. What would that be in kilograms?
45.5.
Thank you. Yeah, so, and if you put that in, you saw you got 45.45454545. You would round that to the nearest tenth to get started. All right, so A tells us that we need to calculate the bolus dosage strength for this individual. So this individual is 45.5 kilograms, and the initial bolus is 80 units per kilogram. And again, I'm just getting that information right from the protocol, either at the very beginning or step 10 of the protocol. So 80 times 45.45, or 45.5, Oops. Gives me 3,640 units. Okay. I don't want units, I want milliliters. So I'm going to go back to step 2 of the protocol where it tells me that I have 1,000 units of heparin per milliliter. And then I'm going to get 3.64 milliliters, and I'm going to round that to 3.6 milliliters. So I only want it to the nearest tenth. If you guys are getting frustrated with the rounding rules, this semester you're going to be doing pediatrics, and the rules are just a little bit different. So application and obviously patient weight and patient age is going to play a role in what kinds of rounding rules you follow. So I just want you to know that if the rounding is frustrating you now, you're going to get a little bit more of it with the pediatric, and there is another pediatric drug test that you'll take during the semester as well. The good news is I worked out that practice test that that you'll probably get from your instructor, and it's on my on the YouTube page, so you can see all the questions. And if you have any questions during the semester, please feel free to reach out to me. All right, B. What is the infusion rate? What do we start them at? So again, 45.5 kilograms. Again, we start with the 18 units kilogram hour. Get rid of kilograms. And then we get and by all means, if you're getting ahead of me, please go ahead and get ahead of me. And then you can just confirm that I'm doing the right thing, or that we're getting the same answers. I used the IV that was given to me, which told me that there were 25,000 units in 250 mLs of half normal saline. Get rid of the units. And then we get 8.19 milliliters per hour, and we're going to round that to 8.2 milliliters per hour. Now, you may not actually be able to program in an 8.2 into your infusion pump, but in the, I always say it's the CCAC drug calc bubble, we're just going to assume that you can, and so just make sure you round to your nearest tenth. C part 1. Somebody give me another APTT. Your choice.
$34.
Okay, 34. That sounds hard. All right. So 34 seconds. So when we look at the protocol, what fits for 34 seconds? Well, that's going to be step 11, right? So I still have the same patient weight. And then what does step 11 tell us to do? It tells us to rebolus with 80 units per kilogram. So we already know the answer to this. It's just the 3.6 milliliters. I'm not going to do out the math again because it's exactly the same. Does that make sense? Don't need to change anything because it's exactly the same. We're rebolusing with the same amount. So part 2 says to increase the infusion rate by now 4 units. So someone tell me what my new infusion rate is going to be in units per kilogram per hour.
$22.
Got it. 22 units kilogram per hour. All we did was add 4 to the 18. Now we do some quick math. 45.5 times 22 is 1,001 units per hour. Then we're going to multiply again by the same IV bag that we have available that has the 25,000 units of heparin in the 250 ml half normal saline. We know we set this up right because we're left with milliliters per hour. And then we're going to get 10.01 milliliters per hour. And then we're just going to round that up to 10. And then I told you, like when I mentioned standards or constants, notice that the bolus, and then we didn't have to do it here because it was the same for the rate, using that same number. Don't change. This was the same for the initial. This came in step 10. And then this came from step 11. So over the semesters, I've had students they'll just tell me what weight they used and what answers they got. And I usually I confirm them. So if you want to work through this and change the patient's weight, change the APTT. But I will tell you that most likely you'll use step 12 because step 12 has you do a new bolus and a new infusion rate. And I can't remember if I said this already. I may have said it earlier. When this question gets asked, you'll only have, so like question 1 would be just like A and B, or it would just be, or one question would either just be A and B, or it'll just be C1, C2. So you won't have both. So this gives you an opportunity to practice the question twice, essentially. All right. Well, if there's no other questions, I wish you the best of luck. If you do have any other questions, feel free to email me. Feel free to check out the YouTube channel. I will try and post this review on the YouTube channel as well. And then I could also send you the link if you email me and remind me. Or maybe I'll even just post it in the folder there. So, so if you don't have any other questions, I wish you best of luck.
Thank you.
Thank you.
You're welcome.
So this is so hard on Zoom. For question 25, so it's either A and B or C, 1 and 2.
Correct. That's what you'll see on your actual test. Yes.
Okay, so do I have to do A and B to get to C, 1 and 2?
Nope.
So if it was just question C, then I would just start with the ATP. So I would start with the kilograms, and then I would start with the rebolus. So the units would be 40 units and chew.
Correct.
And the 40 units is for the bolus, and the 2 units is for the drip.
Correct.
Okay. So
Yeah,
instead of using question 10.
Right. And that's a good you said that perfectly. So like you don't need the initial information to answer. So like I always imagine, like, what if you came into this patient, after the 6 hours mark. So, and you were asked to do this calculation. I don't think that you would be, but you were asked to do this calculation, and it would be based off of the information you know now. So if the APTT said 46 seconds, then you just leave it as is. You would leave it be. But if it said 40 seconds, then you would go ahead and rebolus at 40 units. So you just do that calculation and then increase the infusion rate by 2 units. So you wouldn't need to know the first information to answer the second information.
Well, so I would need to know question 10 though. am I adding 80 plus 40? No.
No, because it just tells you to rebolus with 40.
Okay.
Yeah, so you don't need to know, you don't need to add 40 to that. You just need to know to do 4. So basically what that range and all the other ranges are telling you, like, or the 11 and 12, it's just telling you that they're still clotting too quickly. And so we want to stop that. And so that's why we're rebolusing. But normally we would just want to keep them on a low drip in order to keep them keep the clotting limited, or inhibit clotting, I guess.
Oh, sorry, I was muted.
That's okay.
So my question is, the most important part of the questions 1 through 15 is your ATP graph, and then the 10 and is number 2 important or no?
Yeah, number 2. So the important steps in the protocol for solving the math are steps 2, 10, and then either 11, 12, 13, 14, or 15, depending on the results of the APTT.
Okay, because the heparin is 25 over 250. The bolus is 1,000 over 1. That's not going to change, right?
Correct. Yeah. Like if you do a Google search for heparin protocol, you're going to see this exact heparin protocol steps 1 through 15 as it's labeled right there.
Okay.
Unless it's changed.
So A is asking for the bolus, so we use number 2, and we use the 100 units over 1 ml. And then B is asking for the heparin, so you do 250 over 25, right?
250 over 25,000. Yes.
Okay, so those are never going to change. That is what it is.
Correct.
Okay, so when you get to C, though, that I don't know why I can't get this.
So when you get to C, you just follow the directions in the protocol. So it says the new APTT is 43 seconds, and you just look at what it tells you to do. It tells you to rebolus with 40.
So I'm gonna put 45.5 kilograms, and I'm rebolusing. I'm using the 40 units over the kilogram.
Correct.
And I'm gonna get an answer.
And then you would divide by 1,000.
Oh wait, I'm dividing by 1,000. Why?
So if you're doing the 43 seconds for this weight, the 45.5,
Yeah.
so you would take 45.5 times 40,
Right.
and then whatever that number is.
Oh, units, because we want to get to. No. Go ahead. Sorry.
You were right. Yep. And then because we want to get rid of units and we're talking about bolus, so we would divide by 1,000, and that would give us our bolus amount, which will probably be 1.8.
So that's number 2. We're going to use that 1,000. Right?
I don't know what number 2. Oh, I see what you're saying. Yeah. So step 2 just tells us it's kind of like saying you have augmentin 250 milligrams per 5 ml. It's just telling us what the strength that is available to us. So we have an IV bag that's already connected to the patient. That's the 250 ml half normal saline that has the 25,000 units of heparin. And then we have sitting on the side in a vial, the bolus dose of 1,000 units per milliliter.
Okay.
And so when you give them a bolus, it's going to be, you're injecting that into the IV, and then the drip is just what you have them set on.
Okay.
And
All right.
You always use the bolus dosage strength for solving bolus questions, and then you would always use the heparin in the 250 ml for answering the flow rate question.
So then that would be number 2. I think I'm putting both of them together. That's the problem.
Oh, okay. Yeah, no, you only use one or the other. That's just like telling you, like the way I'm trying to simplify this is, let's just say I have two antibiotics. One is Augmentin and one is cephalexin. I have, 250 milligrams per 5 ml of Augmentin, and then I have 500 milligrams per capsule of the cephalexin. And then I'm just asking you to either, and I'm telling you that you have both those things, but you only need to use the one thing that we're asking about. So for this question, coming back to the heparin protocol, bolus, I want to use the bolus dose. For the infusion rate, I want to use the IV bag.
Oh, I was muted again.
Okay.
So if I was, the second one, if I'm increasing 2 units, I'm using question 10, I'm increasing it to 20.
Right. So because it increased by 2 units per kilogram per hour, you go back to step 10 in the protocol that said you started at 18, and we're going to add 2 to make it 20.
But why didn't I? Oh, because I'm re-bolusing with the 40 units, not.
Right. And then
I'm not using that.
the bolus and the infusion rate are 2 different steps.
Okay. So anytime that I can always go back to that original unit then. And if it says increase by 4, then I'm increasing the 18. But if it's for re-bolusing, then I'm not. I'm
Correct.
just using the re-bolus number.
Correct. You just follow what it says there. So the only places where you would rebolus is if your APT was under 44 seconds.
Mm-hmm.
So under 35 and then 36 to 44 is the only times you're going to rebolus, but you don't even look at the original bolus anymore.
Okay. I think it kind of makes sense.
Yeah.
Because I'm always using number 2.
Right. Number 2 is like, that's your stock. That's what you have on hand and what you're drawing from.
Okay. I think I got it.
Just practice it. Don't worry about it making 100% sense right now. Just practice the math. And like I said, you can watch. I did it on pen and paper on the YouTube channel, and you can watch that there. And then just practice it and do a blank one, choose another weight, come up with the answers, and then email me and tell me what answers you got, what weight you used, and I will tell you if you got it right or not.
Okay. Sounds great.
Okay.
Thank you.
You're welcome. Good luck on your test next week.
Thanks.
All right. Bye.